do record our presentations and make them available up on Twitch when we're done. Upcoming meetings TBD at the moment. We're hoping to kick back off here after kind of a summer hiatus, and not only do evening meetups, but potentially carry on with our kind of agile coffee or agile morning meetups. We're still working out some of the details of all that, but hopefully everyone can join us when we have those going on in the future. We don't have a sponsor this evening. We're still kind of reaching out to sponsors and getting started. It's a little bit chaotic, I guess, still with the pandemic, but we do have a chip-in option. If you are so inclined, you can chip in, help support OneTug and the events that we put on. And we can open the floor if anyone has any community announcements or looking for work or hiring, anything like that. You can feel free to put it in the chat window or talk to us afterwards, and we'll be happy to announce those. And just a little bit about tonight's agenda. We covered the welcome and announcements. Just once again, the recording tonight is going to be recorded, or the meeting tonight is going to be recorded and available on Twitch afterwards. And our featured speaker is Shaun Walker, and he's going to be talking to us about Blazor this evening.
One minor correction. It'll be available on YouTube, not Twitch.
Oh, YouTube. Okay, Santosh,
Yeah,
thank you.
Sorry, I should have got.
No worries. So it's my pleasure to introduce Shaun Walker tonight. Shaun's been a professional developer for over 25 years. He's the original creator of Oqtane and DotNetNuke, web application frameworks, which have cultivated the largest and most successful open source community projects native to the Microsoft platform. He's been a Microsoft MVP and ASPInsider for over 10 consecutive years. And he's currently the technical director and enterprise guildmaster at Cognizant Softvision. So with that, I'd like to turn it over to Shaun.
All right. Really excited to be with this group. It's been quite some time since I spoke to the Orlando group. I think the last time was probably 7 or 8 years ago. And I remember I was actually in Tampa for some other business, and I arranged to speak at a meeting, and I actually drove from Tampa to Orlando to attend the meeting in person. So we weren't doing virtual at that time. So yeah, and I had a good time. I remember we went out for drinks afterwards, and a lot of really great people that I met in Orlando that are part of the .NET community. With that, I guess I can show my screen. All right. Yeah. So I think that that introduction covered almost everything that's here, other than the fact that I'm also affiliated with the .NET Foundation. So the .NET Foundation Project Committee, I'm the chair of that. We have, I think, about 8 folks on that committee. Primarily, the job of the project committee is to review new project applications when they come in, and then make sure that they get onboarded quickly through the process. This was not always happening this way in the past, and the project committee sort of has a mandate to make sure that things get moved through basically within 30 days. So we also get involved in a lot of other matters that are related to open source projects as a result of that, and it's been quite interesting. This presentation that I'm giving today is actually one that I've given a number of times because I kind of got involved with Blazor very early on, and so the content of this has continued to get updated every time there's new announcements around Blazor. So I hope that the talk actually gets better each time as well, but I can't guarantee that. But I'm mentioning that because if you see in the the bottom right-hand corner of the slides, it says that this template's from 2019. So I just want to assure you that the content is not from 2019. It's been updated to more recent content for Blazor. I've also obviously been, I was the creator of .NETNuke, which was a very popular open source project on the Microsoft stack. And because of that, I had the opportunity to participate in a lot of different books that were written related to DNN. Never actually wrote an entire book myself, just contributed chapters to books. I'll tell you that writing books is a lot of work, and I commend those people who really invest in doing that. Because I still think that even in this day and age, books are very valuable. Really, you really, in order to dig into some of these solutions, you need sort of that deeper explanation that a book can provide at times. So I think that that's very valuable if anyone wants to invest in that area. So today we're going to talk about Blazor. I'm assuming that some folks who are attending this talk are already familiar with Blazor, and so there's going to be probably some content that is maybe not applicable to those folks, because I'm going to start right from the beginning and walk through right from the very beginning. Hopefully there's value in doing that. You might learn a few things about how Blazor got started, things of that nature. I'm going to talk about Blazor Server, Blazor WebAssembly, and Blazor Components, and I'm going to talk a bit about Oqtane as well, which is a new open source project that I've been working on that is based on Blazor. So what is Blazor? It's a single page application framework for building interactive web applications using .NET Core. So pretty simple. I'm going to stop for a second and just talk a little bit about single page applications. So I know that most of us are probably involved in building these types of applications probably for like the last 3 or 4 years. However, the way that we've been building these is by building, typically if we're in the .NET community, we've been building .NET based backends using Web API, and then we'd be building a front end using a JavaScript framework such as React or Vue or Angular. And that works well. I mean, there's a ton of enterprise applications that are being built using that model. However, it's not exactly a natural environment for everyone. And so what we often see in our enterprise projects is we have to bring in specialized resources for both the front end and the back end. You kind of lose that full stack nature. Some people, of course, are full stack, but usually people are more specialized in one area or another. And because of that, there's some inefficiencies that happen on the projects, and it's sometimes the resources are not always available. We've had a heck of a time finding front-end resources depending on the front-end framework we're using, so that can be a challenge. So Blazor actually is a single-page application framework, but it uses C#. It allows you to build front-end applications, or basically the front-end and the back-end, full stack using C#. So where Blazor can plug in is on the front-end using Blazor WebAssembly, or it can plug in on the back-end using Blazor Server. However, regardless of whether you're using that WebAssembly model or the server model, basically the whole idea is you're still really focused on building a single page application model, with all of the sort of rich interactive nature of those types of applications that people would expect. Sort of the next generation beyond true server-based applications like web forms and MVC. So going back, I guess, further, when did Blazor actually get started? So there's a popular software conference in Oslo called NDC. And way back in June of 2017, there was a conference. And this is where Steve Sanderson, who works for Microsoft, actually had a session. His session was focused on introducing some new web technologies that might be applicable to the modern web developer. And one of those technologies was WebAssembly, because WebAssembly, it had been around for a while. It had already gained acceptance among most of the major browser vendors, and so he put together a proof of concept. And that proof of concept basically demonstrated how you could write a C# application, deploy it to the browser, and have it run on WebAssembly. So it's pretty cool. And I guess the interesting thing is that none of Steve Sanderson's, even his managers, didn't really know, what the content of his demos were going to be. And so he really blew a lot of people away with this capability, because, of course, prior to that, no one thought that this was really possible. And so that created a lot of excitement. And obviously more time was spent between 2017 and 2018 sort of working on the proof of concept to demonstrate that it was a pretty capable area that Microsoft should explore further. And so in February of 2018, the ASP.NET team announced that they were going to actually move Blazor into their organization as an official project that they would begin working on. They still classified it as an experimental project at that phase, because they didn't want to, commit to shipping an actual supported product yet. But by bringing it into their org, they were allowed, able to put more resources on it and actually, build it out in a more fully functional way. And then you fast forward a little further ahead to April of 2019. That at this time, this is when Microsoft finally announced that Blazor was, capable enough that it was going to be released as a real project. So that was big news because, there was a lot of excitement and people were wondering, when is this experimental thing going to become real? And so finally, Microsoft announced that in April of 2019. If we look at sort of the release trains for Blazor so far, as I mentioned, it started off in June 2017. It was announced in 2018. The official first preview was announced in April of 2019. And at that time, it was merged with .NET Core 3.0, which was, still under development. .NET Core 3.0 shipped in September of 2019, and Blazor Server was part of that release. Following up, there was another release for .NET Core 3.1. Of course, it included Blazor, and a lot of additional enhancements were added at that point, and so that was December of 2019. That is considered the long-term support release still. Which includes, Blazor, there is at least a component of Blazor that's included in a long-term support type of release from Microsoft, and that's Blazor Server. .NET Core 3.2 was released in May of this year. That included official support for Blazor WebAssembly. Even official support, although it was still a general GA release, so not a long-term support release. That release is a GA release. And what we're moving towards now is .NET 5, of course, which will be released November the 10th. So, we're less than a month away from that now. That release, you've got to keep in mind as well, is going to be a GA release. And the next LTS release is not expected until .NET 6, which is going to be November of 2021. So I guess focusing a bit more on Blazor now and some of the details behind it. So there's actually two different flavors, you could say, of Blazor that Microsoft focused on in the early stages. There's both a Blazor Server model and a Blazor WebAssembly model. So the cool part about it is that there's sort of one development model utilizing Razor components, and that component model is common between Blazor Server and Blazor WebAssembly. And so you can sort of choose the hosting model which is most appropriate for your specific application. However, you only need to learn how to develop in Razor components. So we're focused first on Blazor Server because it was the initial supported release that Microsoft came out with when it comes to Blazor. So Blazor Server, like I mentioned, leverages the Razor component model for application development. Utilizes a server-side model. So it's important to note that in Blazor Server, you're not using WebAssembly, right? WebAssembly is not part of this picture at all. And in fact, what it uses for communication between the browser and the server is SignalR. So, .NET Core has its own version of SignalR, and that's what's being used to power your Blazor Server application. If we look at a diagram, you can see that on the left-hand side, you've got your server components. So you've got ASP.NET Core, you've got Blazor running there, you've got your Razor components running there, and you've got SignalR, which has a persistent connection between the server and the browser, and it's actually, sending data back and forth. And whenever there's a user interface update that needs to happen, it's actually figuring out what the, sort of the delta is between what's in the DOM in the browser and what the user interface should look like, and it's sending, that JavaScript, there's JavaScript that's dealing with, repainting the user interface in the browser, and so those incremental changes are being transferred back and forth continuously over a SignalR connection. So that's how.
Shaun,
yeah.
Quick question.
You bet. Yep.
So since it uses SignalR,
Yep.
what's the overhead in terms of the additional transport mechanism required for SignalR, and then SignalR operates at different levels, like long polling and server-side events, and
Right.
So what's the overhead mechanism, because all of that is involved?
Yeah, so there is, of course, some overhead involved, and there's obviously, for every client connection that you have with SignalR, there's like a memory footprint. So there's resources that are required to spin up and retain a SignalR connection. I do actually have a slide on some of the scalability metrics that Microsoft has provided. One thing I would say that, from a high level, when people heard about Blazor Server and they heard about the fact that it was based on SignalR, they immediately concluded that, this is not a scalable solution, right? Not something that you'd want to use maybe in production or in a high traffic type of scenario. However, as people have actually started building these applications in practice, it's actually a very capable model. It's like much more capable than people imagine it to be. So, I mean, it's actually interesting because I think originally, with Steve Sanderson's early proof of concept, and it was all based around WebAssembly, and then Microsoft came out with Blazor Server, and people were like, "This isn't Blazor, right? This is some kind of a server-side Frankenstein thing, right? Using SignalR." However, what's ended up happening over time is that there's actually a large group of Blazor developers that prefer the server-side model, and they're building, enterprise-grade applications on that model, and it's servicing their needs just fine. So. That's just something, I guess, to keep in mind. So it's, I think a lot of people wrote off Blazor Server early on without getting into, experimenting with it to see what it was capable of. I don't know if that answers your question, but I do have some additional slides around Blazor Server, which might help.
Yeah, I mean, it does answer my question. One more request, if you can minimize the box at the right-hand bottom. Yeah, thank you.
Sorry about that.
No worries.
All right. All right, so obviously the benefits of Blazor Server, and this is why I guess Microsoft came out with it first before Blazor WebAssembly. So you still can emulate a single page application architecture using Blazor Server. So you're not, your application won't have full page refreshes like they would in an MVC or web forms application. There's a very quick sort of app startup for the client because it's really just a web app. So you're sending a very small payload to the client browser initially to get your application started up. You do have full access to all the .NET Core APIs. And I think this was the bigger thing that Microsoft recognized was, because it's a server-side model, all of the tooling and, debugging support that you come to expect as a .NET developer works just fine. When you're developing Blazor Server applications. So right from the start, which, in September 2019, when .NET Core 3.0 shipped, there was a very robust tooling model around Blazor Server. And that same model, didn't exist for Blazor WebAssembly because, that's a client-side technology, and it, it required some work on Microsoft's part to allow that to catch up to the same kind of feature set. Another thing to keep in mind is that Blazor Server can support much older browsers. So although WebAssembly is supported on all of the modern browsers today, there still are environments that are using so-called legacy browsers. And in those environments, WebAssembly obviously isn't possible. So, however, Blazor Server can run just fine in that model. And of course, Microsoft shipped that in September 2019 as part of .NET Core 3. So some of the challenges around Blazor, and this is, I think, where initially people made some big assumptions about some of the limitations, are, with SignalR, there's latency. So every user interaction requires network communication, and it's like a persistent connection with SignalR. Also, if you're trying to build an application which has offline support, then because of the fact, that SignalR requires that persistent connection, if that connection goes down, then your application needs to reconnect. And early on, I think, Blazor Server wasn't very elegant when it tried to do the reconnection. However, Microsoft has actually come a long ways in improving SignalR and the reconnection capabilities, as I think as a direct result of Blazor Server. And so if you're building Blazor Server applications now, the reconnection logic, it's actually pretty fluid. Scalability, obviously, there are scalability issues. By default, though, you'd be surprised at how much even the basic, SignalR implementation can handle. And then, of course, you can, if you need much higher scale, you can opt into, the Azure-based SignalR service. So in terms of performance, these were some metrics that Microsoft published about Blazor Server. So this was, they're based this on Azure, but this was like, a standard Azure instance, 1 CPU, 3.5 gigs of RAM, could handle over 5,000 concurrent users without any degradation in latency. So that's pretty powerful, right? That's a lot of concurrent users. And so, and that's, this isn't a super high-end Azure plan. This is, standard plan, which is pretty basic. If you up the plan a bit more to something like a 4 CPU plan with 14 gigabytes of memory, it can scale up to 20,000 concurrent clients. So, and you can see that that's almost like linear, right? So it's like almost like times 4. So scalability might still have some challenges. It's sort of a linear scaling model, but depending on the needs of your application and how many concurrent clients you expect to support, Blazor Server might be able to handle it just fine. Yeah, and the main conclusion that Microsoft had was the main bottleneck for load is based on memory availability because of the fact that SignalR, retains memory for each connection. So that's I think the information that I have on Blazor Server. If we dive into Blazor WebAssembly now, which is sort of the new and innovative area that I think a lot of people are interested in. First of all, what it is not, it is not the reincarnation of Microsoft Silverlight. So that's one thing to note. So, WebAssembly is a industry sort of standard. It's an open specification, and it's supported in all the modern browsers already. It doesn't require a plugin to run. So where, a Microsoft Silverlight app or, a Flash or Flex app required you to download a plugin into your browser in order to run that application code natively, WebAssembly doesn't require that. So like this is not Silverlight. If we do look at some of the attempts over time to run, applications natively in the browser, I think some of us in this meeting are familiar with some of these technologies. I know I'm dating myself by admitting that I played around in building ActiveX controls. Of course, Flash it was very popular for a period of time until some of the device vendors decided that Flash, took up too much system resources and was a little bit too flaky for their devices. So kind of shut that down. That also signaled the death of Silverlight as well. But in more recent years, there has been attempts on other platforms to build some platforms that could run natively in the browser. And so I think Dart is a Google offering. WebAssembly is more of an open industry standard, and of course Blazor WebAssembly is based on that standard. So how did it get started? How did WebAssembly come about? So if you go way back to 2013. There was a very lightweight JavaScript library called asm.js that was created, and it was created, so that you could create could be a low-level target language for compilers. Emscripten is a vendor, and they used the LLVM compiler toolchain to compile C and C++ code to JavaScript, and of course took advantage of the asm.js. And of course that generated JavaScript was compatible with all of the major browsers. WebAssembly came along a bit later. It was pioneered by Mozilla, and it was first released as part of Firefox 22. So this is way back in 2015. WebAssembly had a number of advantages over the earlier, version of asm.js. One of the benefits was that the code could be directly translated into native instructions, and the bytecode that it produced was much more compact than asm.js, and it also wasn't constrained by some of the limitations of the JavaScript language itself. It was been supported in all the major browsers since November of 2017, so 3 years now. That's quite a bit of support. And I think the sort of major thing to keep in mind when it comes to WebAssembly is that it's the first language since JavaScript that's able to run natively in a web browser without plugins. That's pretty amazing. I mean, that's super innovative. And once we get into some of the other benefits of WebAssembly, you'll understand why people are so excited about it. The one thing to dig into is, most of us use JavaScript, right, on a daily basis in our jobs, right, to build applications there. Whether we write the JavaScript or we're using libraries or frameworks, JavaScript is a fundamental part of what we do. However, not a lot of people understand how JavaScript actually works under the covers and how browsers actually have to interpret them. So whether it's, inline JavaScript, which is inside of your HTML payload or whether it's, an external JavaScript resource. The browser has to download that JavaScript. It has to parse it. It has to compile it, and it has to, get it into a form that it can then interpret, which is like sort of like machine code for the browser. So all of that takes time and effort for the browser to do. So where is WebAssembly different? Well, it plugs in directly at that lowest level. So, it sort of pre-compiles and pre-parses the code so that it can plug in at that sort of assembly code level. And so you can cut out a huge amount of processing from the browser by using WebAssembly. And in fact, so this shows maybe a comparison of sort of that same graph that I just displayed, and how normal JavaScript processing works with the parsing, compilation, and optimization and execution, whereas what WebAssembly has to do, right? It basically just decodes it, optimizes it, and executes it. So the overall processing time required for WebAssembly is much smaller, which obviously results in a much more responsive and much more scalable client-side execution model. One thing to keep another thing to keep in mind is I think a lot of people hear about Blazor and they think, oh, this is maybe some kind of a proprietary Microsoft thing. Well, and in fact, Blazor is, but WebAssembly is not. And so WebAssembly is already supported in most of the mainstream programming languages, popular languages like Rust, C++, Java, Python. All of these languages have at least some kind of an implementation for WebAssembly or support for WebAssembly. So, I mean, it makes sense that Microsoft wanted to provide similar support as part of, its environment, as part of the .NET environment. And I think it's great that, Steve Sanderson jumped into this early on, because it meant that Microsoft, wasn't playing catch up so much with all of the other vendors that are out there. I think that they put together a very powerful offering with Blazor, and in some ways are, leading the charge when it comes to WebAssembly, as opposed to being a follower, which is what they have often done in the past with other technologies. So when we talk a bit more about Blazor and WebAssembly, the thing to keep in mind is that in order to run C# in your browser, you need a .NET runtime that's being compiled to WebAssembly. Now, when Steve Sanderson initially did his proof of concept way back in, at NDC Oslo in 2017, there was an open source project called, I think it was .NET Anywhere or something like that, and it was an attempt by somebody at some point to create a optimized .NET framework for running on devices that have, that are kind of resource constrained. That was the purpose of that open source project. But Steve saw that that project could be used to run a WebAssembly application, and so that's what he used initially. Of course, that project actually had been abandoned by the original creator, so there was no maintainer for it, and it actually had a number. It was sort of behind in terms of keeping up with the latest version of the .NET framework, and so it really wasn't. It wasn't something that you could build, a real product on. And so Microsoft acquired Mono as part of the Xamarin acquisition. And it turned out that, Mono was already, had made some attempts to create a version that was compiled into WebAssembly. So there already was a mono.wasm, which essentially allowed, it's like a full .NET runtime that could be used to run .NET assemblies on WebAssembly. So this is where sort of Mono came into the picture. But again, this was, sort of like a proof of concept that the Mono team had been working on. And once it came into Microsoft, I think it probably hadn't received much attention. However, as soon as Blazor WebAssembly became, an official product, then Microsoft had started investing more time and effort into the Mono WebAssembly runtime. So if we look at a diagram of how this works, so you've got, again, your server on the left-hand side running .NET Core. On the right-hand side, you've got your browser. And in fact, you have your .NET code, which is, so when the browser fires up and connects to the server, the assemblies, so the compiled .NET assemblies are transferred into the browser. and then they're interpreted so that they can run on WebAssembly. And at that point, all of the interactions between your application and the browser are actually happening in the browser itself. Of course, if you're writing a single page application, your application probably still needs data. So it's going to, make calls back to the server to obtain data. But all of the user interface interactions are happening in the browser itself. And it's WebAssembly that's making that possible. So I guess the question was, and I sort of answered this early on in the presentation, why do we want to run .NET in the browser? When you have all of these, when JavaScript is the most powerful programming language in the world, there's already many powerful JavaScript frameworks available. We're building enterprise applications on them already. Why would you want to run .NET in the browser? And I mean, this is my perspective, but I'm not a big fan of JavaScript. I didn't start my career building JavaScript-based applications. I always appreciated the robust and rich nature of .NET-based applications. I like the idea of being able to build full stack applications based on C# and .NET, as opposed to having to context switch between .NET and JavaScript. So people I realize are not going to agree with me on that and in fact, JavaScript is a very capable technology. It's proven that over decades. So, but anyways, there are some distinct advantages to running C# in the browser. A couple of those. So .NET is obviously stable, consistent. Microsoft has a rich set of APIs and tools and build infrastructure that you can take advantage of to build applications. C# and F# for that matter are .NET languages that make programming very productive, and they're constantly being improved and innovated. So these are all important aspects in order to make our experience developing applications as productive as possible. You've got industry-leading tools like Visual Studio and Visual Studio Code, which provide great development experience and make you as efficient as possible. And .NET has been really focused, or at least .NET Core for that matter, has been focused on performance and efficiency. Big focus on that in .NET Core. And so, I mean, being able to run that type of technology natively in your browser has a lot of benefits. And I guess on the other side, for those of us who do have to deal with JavaScript on a daily basis, I mean, you've probably recognized the fact that these frameworks have become very, very large over time. Like this particular image here is, someone deleting the Node modules folder from Angular, right? It's a massive amount of files that are part of Node, or sorry, not part of Node, but part of Angular. React is obviously a bit smaller in terms of a JavaScript framework, but I mean, these frameworks are very large, and so it's another sort of reason why some folks are interested in using a more lightweight framework. What are some of the challenges around Blazor WebAssembly? And I have a spelling mistake in this slide, but so framework libraries must be optimized for size. So as I mentioned with the diagram earlier, when a client connects to the server using Blazor WebAssembly, the DLLs need to be transferred from the server to the client. And so, and it's not just the DLLs for your application that you've built, it's the supporting libraries as well. So, all of those .NET Core APIs that you're taking advantage of, those need to be transferred as well. And so Microsoft is undergoing an effort right now to, optimize those libraries for size so that it's not a huge payload to transfer to the browser. But obviously, that's going to take some time and effort on their part to do that. They're also experimenting with, compression as well. So gzip compression and other types of compression, again, to reduce the size of the payload. The other thing to keep in mind is Mono, in its current form, only supports .NET Standard 2.0. So, I mean, if you're going to build Blazor WebAssembly applications, you can't target the full .NET Core 3.1, sort of API surface layer, right? You can only, take advantage of .NET Standard 2.0. So that is a limitation to keep in mind. At least in the early stages with Blazor WebAssembly, the debugging support was kind of limited. Microsoft has been working to solve this problem as well, and I believe they did come out with some better tooling in .NET Core 3.2, which was in May. However, I think that where you're going to see the much better support will be in this .NET 5 release that's coming in November. Blazor WebAssembly was not officially supported either as it's a real supported product from Microsoft until May of 2020, which that's only like 4 or 5 months ago. So this is still very new technology. Although I know that there are people that have even been building production applications on Blazor WebAssembly, for the last couple of years, and just taking the risk, right, of work, of rolling it out on an unsupported platform. So it has been fairly capable for quite some time, but official support from Microsoft is important, and that only happened in May. Looking towards the future, Microsoft has kind of laid out like a roadmap for where Blazor could go in terms of additional hosting models that it can support. So, I mean, you had Blazor Server from the start. You've got Blazor WebAssembly now. There's already a template that is shipped as part of Blazor WebAssembly today that allows you to create an application that has progressive web application capabilities. So, it uses Service Worker. And it's actually not that difficult to enable sort of PWA type functionality in a .NET-based application. That's not only applicable to Blazor WebAssembly. You can also do the same thing on Blazor Server, but the templates from Microsoft don't enable that by default. And looking towards the future, I mean, there's some additional proof of concepts that have been created. For example, using the same exact Razor component model, but then hosting those within an Electron shell, for example, to create a desktop-based application, right? But using the same exact Razor component model. So I think you're going to be seeing more of that in the future. I don't believe that some of these options are even expected to be shipped as part of .NET 5. They still sort of only exist as POCs. But there's definitely a lot of work going on around Blazor and the Razor component model. One of the other things which is available right now, and this is sort of ties in with Xamarin, is that there is an experimental project that allows you to build native and hybrid mobile apps using C# and taking advantage of the Razor component model. And so you can go and download those mobile Blazor bindings today. That this is all available, and this is obviously something that the Xamarin team is looking at as an alternative to building XAML-based Xamarin applications. So an alternative model, but it's still not clear where this one is going, and then it's still classified as experimental. So I don't know if it's sort of going to end up being sort of the approach that is used. I don't know yet how this ties into Maui either. So I think Microsoft still needs to paint out a clear vision of the future when it comes to some of these things. If we dig into Blazor a little bit more now and talk a bit about the fundamentals of building a Blazor application, we could talk about how to get started with it, talk about the component model a bit, routing, which is a fundamental part of a single page application model, how to do layouts, how to do event binding, dependency injection, and JavaScript Interop. I'd say that these 7 things, or at least these 6 things, are probably the fundamentals that you need to understand when you get started with building Blazor-based applications. In order to get started, you can go to the official download locations, and you can download the latest version of .NET Core 3.2, the SDK. I would suggest using Visual Studio 2019 Preview Edition because Microsoft continues to enhance and evolve the Preview Edition at a much more rapid pace than this, the officially supported version. And because Blazor is such a new technology, it tends to it tends to get more benefit from using the more recent releases of Visual Studio. So I personally I'm using just Visual Studio Community Edition, right? I'm not even using Professional or Enterprise Edition, and Blazor works just fine in both WebAssembly and server mode in developing applications in the the community edition. If we look at the component model, and this is the the Razor component model, basically what they are is self-contained chunks of user interface that include HTML markup. They include backend programming logic, and they are designed to be flexible and lightweight. And I think the cool part about this whole component model is that they really promote code reuse. So you can share components within the same project, or you can share components across different projects as well. And if we think back to some of the earlier sort of iterations of Microsoft technology, I mean, let's go back to web forms, for example, or even some, I guess, Windows forms to some extent. You had a really rich component model there, right, where you would use third-party components and they would allow you to accelerate your development efforts. As the technologies evolved into newer things such as MVC, we lost some of those capabilities. It didn't have nearly the same robust component model, and hence the ability to reuse code became a lot more challenging. Blazor brings all that back again through the Razor component model, which you're already seeing component vendors coming out with very rich third-party component libraries, which you can use in Blazor applications. And I would imagine, I can only see that happening more in the coming years. In terms of how this all works, so for those of us who are familiar with JavaScript frameworks such as React, like React has a really nice component model that's built into that framework. And I think that Blazor, used some of those JavaScript frameworks for inspiration in terms of coming up with, what was needed to build a robust development model, like a component model using C#. And so here you got a browser on the left-hand side. You've got like a component, right, which is embedded on your page. It's just a chunk of user interface. That component is a Razor component, and it's going to react to routing. So changes to the route. It's going to contain markup, which is your user interface code, standard markup. So this is HTML, CSS. So using this typical web standards. It's going to have backend logic that's written in C# rather than JavaScript. And then you've got, event binding and property binding sort of tying those together so that you can have a really robust development experience. If we dig into the component rendering model a bit more, so you can see sort of from left to right some of the different aspects that are part of the rendering. So on the left-hand side, you've got your C# code. Basically, similar to the way that JavaScript frameworks work, in terms of keeping like what's called a shadow DOM, and doing basically evaluating the difference between the real DOM and the shadow DOM, and keeping track of the changes, and then only repainting the screen in those particular areas which actually had changes. So that's a very efficient model. That's the model that Blazor uses. And so of course you got your C#. You've still got JavaScript. Whether you're actually writing JavaScript yourself, you shouldn't have to do that with Blazor. You should be able to rely on writing everything in C#, but you have to realize that under the covers, JavaScript is still being used because it is the language that browsers understand, and it's what's actually taking care of handling the updates to the DOM under the covers. So you can see how the flow kind of moves from left to right and back again when events are raised back to your C# code. UI differences are then sent back to the DOM as changes. If we consider WebAssembly, keep in mind that all of this runs within the browser. So the C# code, the JavaScript, the DOM, all of this interaction is happening within your browser. Whereas in Blazor Server, you've got sort of you've got to keep in mind that some of this interaction is actually running on the server and some of it is running on the client. And you can see that there's those three arrows there for the render tree, events, and UI differences. the transport mechanism, which is sending those types of information back and forth between the server and the client, is SignalR in the Blazor server model. And so it is what you would consider to be, I guess, a chatty type of a model, right? There's a lot of interactions which are happening back and forth, but because SignalR is a persistent connection, it doesn't have to obviously spin up a new connection every time, which is typically where performance bottlenecks happen. So because it's a persistent connection, you get a very fluid user interface experience. So looking at components, so I mean, components are written using a very familiar syntax, right? You write your HTML elements just like you would in any other sort of programming language. You reference your components in a similar way. So in this particular case, there's a title component, and that title component behind the scenes basically just displays some text in an H1 some H1 tags. So the component is actually the code that's at the bottom of the screen, and the consumer of the component is the code that's at the top of the screen. So basically, that's how components are represented in your code. So it's pretty straightforward. I mean, I've heard people say this reminds me a lot of web forms, or I guess even maybe MVC tag helpers to some extent as well. But I mean, it's a model that should be fairly familiar to Microsoft developers already. One thing that you have to become familiar with is, if you're building Blazor components, it's not a requirement, but they usually inherit from ComponentBase. ComponentBase provides you with, some functionality so that's built in so that you don't have to deal with sort of the native aspects of Blazor components. So it gives you some lifecycle events, such as like on initialized, on parameter set, and on after render. These are sort of the main ones that you'd have to become familiar with. And of course, they're invoked at certain times within the life cycle when your application is running. So on initialized is just like it says, it's called when a component is initially initialized. On parameter set is when the public parameters that are specified for a component, when the values that are passed through those parameters change, right, which could affect the underlying behavior of that component. And then on after render is called after a component has finished rendering, and it's usually used when you want to call out to JavaScript. So typically that's where your JavaScript interop would happen, is an on after render. One thing to keep in mind, which is sort of the, if you get more into the details of what's actually happening in Blazor components and in Blazor, you'll see that the code that you write on the left-hand side, which is very kind of intuitive and understandable, is actually sort of translated into a completely different version on the right-hand side, and it's stored in a specific folder. So if you build a Blazor application, you can look in the obj debug folder and look under the net standard 2.0 library, and you'll see all of the basically equivalents for all the Blazor components that you build. There's equivalents for those in that folder, and they're named with a .razor.g.cs. You could actually write that code on the right-hand side if you wanted to, right? You could write sort of that native Blazor component code. However, if you look at it, it's very, very verbose, right? It's every single user interface element is kind of broken down to the lowest level of granularity, as you can see there with all those builder.openElement and add content, and it's not a very productive experience. I would say, though, that the area where this is helpful is if you're interested to see under the covers how certain higher level concepts are implemented, such as how certain types of events are raised or handled within Blazor. Clearly, there's sort of a higher level and a simpler way of dealing with that. But if you're very curious on how it's implemented under the covers, you can take a look at those generated files, and you can see how it's actually done. And I've had to do this on a couple of occasions where, I was curious on how to do something a little bit more innovative, something that perhaps wasn't easily supported through the higher level constructs, right? And I actually was able to take advantage of the lower level capabilities. Routing is a very standard concept in any single page application model. Blazor makes that very simple by having this @page directive, which you declare at the top of your Razor component. So if you declare the @page, and then you of course declare your route there, and so then obviously when you navigate your browser to that particular route, it's going to invoke this particular Razor component. Not all Razor components need to have an @page directive, because some Razor components are actually not intended to be routed to directly, right? They're components that are intended to be embedded as part of another component. So, but anyways, to do routing, this is the standard way of doing routing within Blazor, and it's pretty straightforward. And just like when you've dealt with routes as part of your MVC applications, it supports parameterization, so that you can extract runtime parameters from the route as well and deal with those. So it has similar capabilities as what you've been using previously. Layouts are also supported, so you can, similar to like a master page kind of a concept, you can build a layout, and then you can embed your Razor components as part of that layout. In this particular case, you've got a layout. That layout has markup, which defines sort of the look and feel of your page. It's got a component on it for nav menu, which is defined somewhere else, and it's got this @body keyword as well, which is basically another Razor component, which is going to be embedded there at runtime. Data binding is handled very simply by having variables that you define in your code, and then by referencing those variables in your markup with an @ sign. You can reflect the values right from your backend code into your sort of front end markup. So that's data binding. Two-way data binding. So this is sort of round tripping, information. So in this particular case, you've got an input control that's part of your UI. It's going to both display the increment amount, which is a variable that's declared in your C# logic. At the same time, it's going to allow you to extract the value that the user entered into that particular input field. So that's how you can, retrieve the data that's entered through the user interface into your application and utilize it. And then you've also got event binding. So by default, Microsoft has provided support for, I think, most of the major events that you would expect on HTML elements. For example, you've got the button here, a button element, and onClick is already, supported, and you can wire it up using @onClick. And you simply put in the name of the method that you would like to call in your backend code, and it will call that method. You can pass parameters to those methods as well. So again, very simple kind of model to get familiar with if you're going to build Blazor applications. Because Blazor is based on .NET Core, and .NET Core, has really deep support for dependency injection built in, Blazor has dependency injection support as well. You can inject your dependencies by using the @inject declaration in your Razor component, and so that's the way you can pull in all of your your dependencies and utilize them into your code. JavaScript is a little bit more tricky, and this is something that I think people who start getting deeper into creating Blazor applications still have a lot of difficulty with. So in its initial form, Microsoft provided a capability called JavaScript Interop. You had to craft your JavaScript in a certain way, like using a specific format. That format is on the left-hand side there. So you declare, you have to declare it in this way. So you'd have like a window.interop wrapper around your methods, but you have to actually write your methods, your JavaScript methods in a certain form, which is kind of different than the form that most people are probably used to when they write JavaScript functionality. However, if it's written in this form, then you can write a C# method which can directly call that JavaScript. And you do that by using the JS runtime capability that's part of Blazor. And so you can see on the right-hand side there, it's using that JS runtime capability to invoke a JavaScript function. And of course, you can pass parameters and do things. You'll also notice that everything in Blazor is pretty much asynchronous. So that's another thing that if you're not that familiar with asynchronous programming techniques in .NET, you're going to have to become more familiar with it if you're writing Blazor applications. But in .NET 5, Microsoft has actually added some improvements when it comes to JavaScript Interop. There's an alternate way that you can define your JavaScript, basically defining them as JavaScript modules, using the export keyword for those of you who are more familiar with JavaScript, and then you can actually declare in your C# code the external path to that resource, that JavaScript file, and it'll take care of loading it for you, and then you can invoke the methods on it. So this was an area that was a bit weak in the early versions of Blazor, and Microsoft's in .NET 5 is going to have some improvements there. So one of the questions that you get is, so it's great that you can build Razor components and you can host them in multiple ways. So is it possible to write one application that can target multiple hosting models? And the answer is yes. However, you do need to pay attention to the architecture of your application, right? You do need to pay attention to the fact that it is a client-server model, right? So you need to pay attention to where the various workloads are being performed. And I say that because, as a practical example, if you're creating application logic in C#, and you're attempting to perhaps interact with a database directly or interact with a file system directly, and you try to run that application on WebAssembly, where you're sort of in the web browser sandbox, it's not going to work, right? You can't talk directly from the web browser to a database or to the server file system, right? Using things like system.io. Right? That's not going to work. So you have to pay mind to how your application is architected. So in those cases where you do need to interact with a database, it's a client-server model. So your front end is going to have to talk to your back end through a web service of some sort, right? Like a web API service, and your back end code is going to be able to talk to a database, right? So the same way that you build applications on JavaScript frameworks like React or Angular, you have to follow that same exact approach when you're building Blazor-based applications. And sometimes that's not immediately obvious because of the fact you can write C#, right? You might mistakenly think that you have access to all of the standard things that you typically can do on server side in C#. And when you run your application, you'll find out, yeah, no, that's not going to work in Blazor WebAssembly. So that's one thing that you have to keep in mind. So you just have to put on your architecture hat and pay attention to where the workloads are. The other thing is, with Blazor WebAssembly, like I mentioned earlier, you can't access all of .NET Core 3.x, right? Or as far as the API surface layer, right? You can only target .NET Standard 2.0. I think another thing that you have to maybe become familiar with is there's maybe some subtle differences between some of the JSON parsing and the HTTP client behaviors. So Microsoft basically had to, for Blazor WebAssembly, Microsoft had to build a special version of HTTP client, which is capable of running in the browser. Also, the versions of JSON.NET that we typically have used for years take advantage of some pretty innovative things related to reflection. Those don't run in the browser. So Microsoft had to actually introduce, a new JSON parser. I think it's in system.text.json And it was, of course, introduced as part of .NET Core 3.1, and there's been a lot of performance improvements that are coming as part of .NET 5 there. So these are some things you have to pay attention to if you want to write one, like, an application that can run in both environments. And then, as I mentioned, everything is async, right? So the whole concept behind Blazor, at least from a user interface perspective, is that you don't want to block any user interface threads, right? So everything from a user interface perspective should be written asynchronously. And the whole model has been set up that way. So, and of course, I mean, for those of you who have any experience with asynchronous, you know that it's almost like a cancer. Once you go down that path and you start using async, pretty much everything has to be async, right? It's hard to context switch between sync and async. So that's something you have to adjust to. And so I think that covers pretty much everything that I was going to talk to related to Blazor itself. And then I was going to talk a bit about Oqtane, which is an open source project that I've been working on, which is based on Blazor. Before we go there, though, are there any questions related to Blazor?
So I guess our question is, it seems like Microsoft released the server model first, and then they made the client model GA recently. Am I getting that correct?
You're correct. Yep. Yep.
Okay. So, like, how did that impact any applications that might have gone into production using the server model? Because obviously, the client model offers you far more flexibility.
Yeah, I think I understand your question. So
Yeah.
I think that people who put applications into production using the server model probably did so deliberately, right? I think that they probably would have done their homework, determined that the server model met their needs, and probably didn't expect to use the WebAssembly model in production at all, right? So because usually, like, the server model has fairly different characteristics than the WebAssembly model. And I know it's easy. It's the assumption that most people have is that, if you have the option to use either model, why would you ever use the server model, right? I think that's the question that most people ask. And in fact, there are cases where the server model is actually probably superior to the WebAssembly model. And I say that because if you want to have if you're building like a typical kind of a web application and you want to have a super responsive experience for the end user when they connect to your site, Blazor Server is still way faster for that initial experience for the end user than Blazor WebAssembly, simply because of the fact with Blazor WebAssembly, if it's a new instance connecting to the server, it has to download a lot of stuff to get up and running. So it kind of depends on the characteristics of the application that you're building. I know a lot of people are building production applications for internal use using Blazor Server. So I think people shied a little bit away of using it in a public-facing, consumer-facing type of application, but for an intranet and for internal applications, Blazor Server is used a lot. And there's those people who've built those types of applications have no plan to upgrade them or migrate them to Blazor WebAssembly.
But what's the effort it would take to migrate them, I guess?
So it depends on how you built it. So if you built a Blazor Server application and you took advantage of the fact that you can actually, in a Blazor Server application, call databases and call the file system, and because the workload is actually happening on the server. So if you wrote your application in that way, then basically you're going to have to do a lot of rework, right, to turn it into a true client server application. However, if you built your application in a client server manner where you actually properly separated things, so you've got a front end, you've got services connecting to the back end, and you've really distributed the load, there's almost no effort involved to run it on Blazor WebAssembly.
Okay, got it. Thank you.
Yeah.
I have one quick question about WebAssembly. You mentioned just the kind of the initial startup time of Blazor WebAssembly, just having to download that payload to the client.
Yep.
How much of that is cached for future use if somebody comes and revisits? And secondly, how easy is it to invalidate that cache if I have a new update to my components that are coming down the wire? Do I have any special hooks or anything that I'd have to do differently to update that, or is it just basically version the assembly itself?
So to answer your first question, it absolutely does use caching. So once it's downloaded that information one time, it takes advantage of all the standard caching techniques that are available for like external resources in the browser. So it shouldn't have to download it again. As far as cache invalidation, I actually don't know the answer to that question. I don't know if there's a very special technique that that is built into Blazor that allows you to do that more easily, or if it's like, for example, if you recompile your DLLs, right? Is it going to notice that those DLLs changed, and is it going to do some magic behind the scenes, right, to invalidate the cache? I'm not sure the answer to that.
Okay, fair enough. Thanks.
Could I ask one question about just language support for other languages? I mean, it seems like Blazor is pretty tightly coupled with C#, but Wasm, I guess, gets people thinking about whether some of it could be ported over to be kind of language agnostic. I mean, is that a thing that could be on the roadmap or something that's considered, or is it pretty much a hard C# expectation for all intents and purposes for the future?
So is your question like, would it be possible for Microsoft to provide support for Blazor in like Visual Basic and F# and other Microsoft-based languages, or non-Microsoft-based languages?
I guess, yeah. I mean, sure, F# would be probably, yeah, another .NET language probably be very much the most obvious thing.
Yeah, I have not seen any examples of this concept, but I don't see, like, because of the fact, you build your application and it's the DLLs, right? It's the MSIL, right? It's the DLLs that are shipped to the browser. Whether those are built in F#, VB, or C#, it shouldn't matter, right? And that, because once it's running in the browser, it's running on, well, I guess where it might be a problem is mono, right? So there's mono underpinning this, and what kind of support does mono have for VB? No, or would that even matter? I guess it would if you were using specific VB libraries. Maybe it'd be a problem. I'm not sure. It's a good question. The only examples that I've seen are C# based examples, and I don't know if that's because it's not possible to use other languages currently, or if that's just Microsoft's favorite language. I don't know. I
can't personally imagine wanting to do anything except C#, but just kind of curious. I know there are people out there who don't know C#. Maybe they prefer Python or something, and if there's some roadmap that gets kind of a consistent UI framework where people can write stuff in their own language and have it port to Wasm or whatever. But anyway, it does seem like an extremely complicated problem.
I think that is possible. I think so. Wasm, right, is more of an industry standard, and so you can build WebAssembly-based applications using like Rust or Go or Python, and they have similar concepts as Blazor, where you can run that code on WebAssembly in the browser. So that is possible already.
But it's definitely well outside the sphere of Blazor.
Oh yeah. I think that I don't know why Microsoft would even be interested in promoting that, but
right.
Yeah.
Can I ask one last question? Is Edge going to come with a Blazor runtime embedded in it? So
I believe,
there's
yeah.
no. It is okay.
It already supports Edge. Already does support WebAssembly.
Just right out of the box. Okay, that's cool.
Mhm.
All right. Well, thank you.
Yep.
All modern browsers support WebAssembly, right?
Sorry, I didn't understand.
No, all modern browsers support WebAssembly. Is that correct?
Yep. Correct.
Okay.
Yep. Yep. Even like Safari, right? Like, so yeah, Chrome, Safari, Edge, Firefox.
But if people are concerned about the download time, does Edge come with it bundled? So if you've downloaded Edge, you don't have to then go potentially download the Blazor runtime? Or
Not right now. It doesn't.
okay.
Yeah.
Just curious. Okay, thank you.
Yeah. All right. So I have I think a bit more content here. So application frameworks. I think most people are familiar with application frameworks and why they exist and why we use them, because they allow us to accelerate, the development of applications, and they allow us to build things in a more standard way, and they automate, some of the overhead, which are, the things that you have to do over and over again in every application, right? That's why people use frameworks. And of course, there's different kinds of frameworks. There's like full stack frameworks. There's frameworks that are only for the front end, only for the back end, right? So there's a variety of different frameworks that are out there. So the Oqtane framework, which is a framework that I've been working on, is built on Blazor. And the idea behind it is that it allows you to build sort of a modular-based application. And if for those of you who know my background, I created .NetNuke, which was a web forms-based framework long time ago, like 2002, I think the original version was released, and it's still being used today. And the whole concept behind it was that, instead of building applications as like monolithic implementations, you could break it up into modules. And so the whole idea behind the Oqtane framework is that we want to provide a modular framework which accelerates development, and with a big focus on extensibility, which was part of DNN, and productivity and speed. So the Oqtane framework was inspired by DNN. However, the thing I like to point out is it is not intended to be a content management system. Like when I think of a content management system, I think of a system built around the notion of a content repository with like content versioning and workflow and content localization and all these content related features. And that is not what Oqtane is. Oqtane is designed to be a modular application framework where you would build, custom applications and plug them into this framework. .NetNuke did have those capabilities as well, but over time it kind of morphed into a content management system. So there is definitely a difference between the two. The idea behind Oqtane is it should give you, a set of building blocks that you can build application with on Blazor. And I guess the sweet spot is, you can certainly spin up a Blazor application using the standard templates that Microsoft provides through Visual Studio or Visual Studio Code, but those are very, very basic applications. If you want something that's a bit more robust and perhaps has, a lot more functionality wired up automatically for you, this is sort of the sweet spot for a framework like Oqtane. Like I said, it's written natively using Blazor, open source license. It's actually part of the .NET Foundation. It's an official project. And it also provides some capabilities that are not even available in Blazor currently. Some of those features are it's completely built on a multi-tenancy model. So, and obviously, Blazor doesn't support multi-tenancy out of the box, neither does .NET Core, and it takes some fairly heavy lifting to build a multi-tenant application. So Oqtane has that capability built in. It has dynamic routing capability. So instead of embedding or hard coding your routes into your Razor components, right? That's all abstracted and dealt with through configuration in a database. So it's fully dynamic. It's got a UI framework that allows you to deal with, the user interface aspects of managing sort of a portal of different widgets that you can sort of build at runtime, put together. So you don't necessarily have to be a web developer to build out, a kind of the user interface. It's got modular architecture. It's got a more robust permissions model. So it's got like the standard ASP.NET identity for authentication and authorization built in, but it also has a more robust authorization model as well. It's got the ability to have customizable themes going, a bit further than what Microsoft has provided with their basic layout concepts. It's got a admin user interface with a lot of functionality sort of pre-built for you, so you don't have to build it from scratch. And it's, fully client server, so it's got like a full headless API, with services exposed with Swagger endpoints all documented and a repository. One of the interesting things is, like, one of the goals behind it was I wanted to build an application that supported both client side and server side Blazor in the same code base. So Oqtane does that, is actually doing that. So we have, one application that we ship, and you can run it in either Blazor Server or Blazor WebAssembly simply by changing one setting in an app settings file. It's got a custom router. So these are some of the more advanced, I guess, Blazor capabilities. So if you're interested in learning about Blazor and you want to see some example or reference implementations of how to do some more advanced things, Oqtane is a good place to look. So like most applications, I think, use the standard router that comes with Blazor, but Oqtane uses actually a custom router, and it shows you how you can actually create a custom router for your custom needs. It uses dynamic components. So where the examples that I showed earlier actually, again, had like sort of components that were hard coded into other components, right, and referenced statically, Oqtane allows you to deal with that all dynamically. So it spins up components dynamically and injects them at runtime into your overall user interface. Utilizes cascading parameters, which are a very convenient way of passing application state between different components. Already mentioned auth, and it has quite a few sort of more advanced JavaScript interop functions, which allow you to do things which weren't possible as part of the initial Blazor release that Microsoft shipped. From an architecture perspective, it is a client-server application, so you can see, I guess, the different components in this diagram. So on the server side, you've got a full REST API using Web API and Swagger. It's got also a scheduled jobs capability using the .NET Core, what's it called, scheduled service capability. So you can actually run scheduled jobs as part of your backend server application for doing sort of background or asynchronous processing. It's only designed right now to run on SQL Server. That can be, SQL Server Express. It can be local DB. It can be Azure. But it is designed for SQL currently. It uses EF Core exclusively, like no store procedures or anything like that. It's all ORM based. On the front end, it's running either on Blazor Server or Blazor WebAssembly. It's got a whole set of services that you can take advantage of on the front end, which are already wired up to talk to the backend APIs. And it's got a portal UI framework and the ability to plug in modules. The module architecture, the way you would build a module is exactly the way that you would build any other sort of client-server application. So a module would have a client front-end component. You can have a shared component to share your models between the front end and the back end if you want to, and you'd have a server-side component to them. And there's examples of modules which already exist with full source code, so you can see how they work. If you're interested in taking a look at the code, you can go to GitHub. So github.com/Oqtane and Oqtane framework. There's a fair bit of activity that seems to be going on there. As far as roadmap, I originally, so kind of, I guess the story around this is Scott Hunter reached out to me in 2018, asked me if I had, taken a look at the early forms of Blazor, because he sort of knew that I always was a big fan of the component-based application model. And so I did take a look, and I thought, wow, this is cool. I think I could build a proof of concept around this, which would emulate some of the things that I had done in DNN. So I did start writing that, and I sort of started writing that proof of concept on Blazor Preview 5, which this is like before Blazor even was shipped as a 1.0 release. The official announcement of and the creation of the actual open source project for Oqtane happened on May 5th, 2019. We shipped Oqtane 1.0 on May 20th, at the same time that .NET Core 3.2 was released, which provided support for Blazor WebAssembly. And we've had a number of stabilization releases since then. And our plan is to release Oqtane 2.0 release on November 10th, on the same day as .NET 5 is released, because we already have it running on .NET 5. I guess I can show you a little bit about, what it looks like. So the source code that I have here, it would be the source code that you would get if you, went to GitHub and got the latest code from the main branch. It's broken down into the standard sort of client-server component projects that you would expect. So you got your client project, server project, and a shared project. Client project contains all of the Razor components. So if you're interested in looking at a lot of examples of different types of Razor components, you can go in the client project, go in the modules, go in admin. You can see like there's a whole bunch. These are all separate modules, but they're all built on Razor components. So a lot of functionality that's already built out, and you can use as sort of reference examples if you want to see how Razor components work. We've got a whole set of services, which are sort of API wrappers that make it easier to call from C# code to interact with the backend. So those are all part of the client project. If you look in the server project, we've got our controllers, which are our web API endpoints. We've got our repository, which is sort of a separate repository, deals with all the data access using EF Core. And then I guess the shared project is where all the models exist currently, and the models are shared between the front end and the back end. I realize that not everyone likes that approach. Some people like to have dedicated, view models for the front end, but this is the approach that we've used for the architecture in Oqtane so far. If you look in the server project and look at the app settings.json, this is sort of the single configuration file that exists in the overall solution. This is the connection string to my database. There's actually an installation wizard. So if this, by default, when you first set up Oqtane, this connection string will be blank. And when you run the application, it'll automatically invoke an installation wizard, allow you to provide your database details, and then it'll install all of the necessary database scripts for you. This node here is what I was talking about earlier in this meeting about the fact that runtime by default is running on server. If I change this value to WebAssembly and I run the application, it'll be running on WebAssembly. So it's really simple to switch back and forth between the two different hosting models. So if I go ahead and run this, this is obviously running on Blazor Server. And I prefer to use Firefox for my browser, but it has some very basic content that is installed by default. For those of you who are familiar with DNN or .NETNuke, right, you'll see a lot of similarities to the way that the user interface works. I can go into sort of like an edit mode, and I can see that there's different areas that are part of this page which contain content. There's like this is a component here for rendering some basic HTML content that is stored in a database. This is another component instance here and another one here, and they all have different security configurations around them. Because like if I go into the settings and I have breakpoint set, and so I can see some of the different configuration options that are available. This is also, of course, stored in the database and the permissions that are set up. So Some of this should be if you've ever used DNN, then should be very familiar to you because the UI concepts are very similar. If I go into the control panel, this is how I can add additional types of modules to any page on the site. I can also go into an admin dashboard. And so these are some of the admin functionality, which is already built out. So the ability to manage your users, manage your roles, manage your files, upload new modules, manage your site settings, look at your event log, interact with your database, running your background scheduled jobs, restoring content from the recycle bin. So there's a lot of stuff here that is already built out for you. And the idea is this is the standard sort of framework stuff that you shouldn't have to build. You should focus on building custom applications, which are your modules, which you can then host as part of this framework. So that's the basic concept behind it. I've been talking for a really long time, so I think I should probably stop and take any additional questions. If there are any.
What would you say is the, besides just kind of supporting the new .NET 5 release coming, what else is coming in the in the 2.0 release of Oqtane that isn't available or won't be available?
So there's just sort of two major things. One is just making sure that we have full .NET 5 support, and that's actually just at this point it's just compatibility, making sure that we can run on .NET 5. We're not taking advantage of many of the new capabilities that Microsoft has introduced for Blazor and .NET 5. Those will have to come a bit later. And the second major thing is what we call static localization. So the ability to have or to change all of the, I guess, user interface of the application into different languages, which was a fairly key aspect of .NET.Nuke. It really allowed developers from all around the world to build applications in their native language. So that was a pretty key feature that we felt needed to be added to the framework as part of 2.0. And then the roadmap beyond that, there's a lot of things sort of on the list, but we need to kind of prioritize and see which things should come after that.
Excellent, thanks.
I'm showing this particular slide here because I was lucky enough, I guess. I've submitted abstracts to .NET Conf quite a number of times in the past and never got selected. So I was pretty excited when I actually got selected for this year. So I have a session at .NET Conf on November the 12th, and it'll be focused on, building dynamic applications with Blazor, which is essentially exactly what Oqtane is. So but I'll have to put together a more focused presentation to demonstrate some of those capabilities.
Is that, oh yeah, .NET Conf was, is that like the 24-hour thing?
Yep.
Okay, yeah.
Well, and I think this year it's 3 days, so I think that they expanded it and added a lot more sessions. Well, and partly because it's the official launch of .NET 5, so it's timed with a fairly major release. So there'll be a lot of content, I'm sure, that gets shared.
Nice.
Yeah, so if anyone has questions on, Blazor or Oqtane or the .NET Foundation or any topic, feel free to ask. And if not, I really appreciate the opportunity to speak to this group. I hope that there was a lot of valuable information in this presentation. Like I said, it has evolved a lot over time, but it's a topic that actually I really enjoy talking about. So.
No, it was great. So from my perspective, I'm more of, for lack of a better word, I'm not front end. So, yep. But I do know, I'm fairly comfortable with C#. So this kind of gives me the basis to go and learn more about Blazor, knowing that it has a SignalR in the backend, which I've used in the past, and other things like there's the server model, there's the client model, and so there's definitely it's a good launching pad. Now, one question I have is, do you have like a recommendation on some kind of book tutorial or anything like that that I can just take and power through it and kind of become comfortable with Blazor?
Yeah, so one of my colleagues who I've worked with a long time, Michael Washington is his name. He, I know that he has a book that he published, but I can't remember even which publisher it came out, but he published a book about Blazor early on. I know that Chris Sainty, who's a pretty notable person, I guess, in the Blazor community at this point, because he got involved early on and he publishes a lot of great content. He is writing a book, and I think he's actually releasing the chapters as he completes them, so you don't have to wait for the entire book to be done. But he's a great writer and has a huge depth of understanding in Blazor, so that's another good source. And then, if you want to, of course, look at source code and run an application and walk through how it functions of Oqtane is a good. I think that I don't want to sound like boastful or anything, but I think, factually speaking, Oqtane is one of the largest open source implementations of Blazor at this point in time. So, it contains like a lot of great examples. So if you're looking to try to figure out how to do various things in Blazor, you can probably find a working example in Oqtane of how to do it.
Got it. So second question, like, are you, other than Oqtane, like, are you aware of any production workloads running in Blazor that they can point to that would be like a good, hey, Netflix is running on Blazor. I know Netflix is not, but
yeah, I don't have any examples off the top of my head. I know that someone told me about who is it? Deloitte. So I think you're familiar with Deloitte, right? I believe that they've deployed Blazor applications on Blazor Server into production, but I'm not sure if I haven't seen like a good showcase site, like show me your Blazor site kind of thing to see some of the examples of people and what they're running in production. It'd be great to have that, because I think that that's one of the things that's holding back adoption at this point is, show me some examples, like who's already kind of dove into these waters, right? And I don't want to be the first.
Right.
Yeah. I guess one other clarification on something you mentioned. So you although I've mentioned SignalR a lot of times in this presentation because it's like the underpinnings of Blazor Server, you really don't need to know anything about SignalR. That's all sort of infrastructure that's hidden behind the scenes when you're developing Blazor applications. There is actually zero configuration required. So yeah, it's not like if you've never used SignalR in the past, that's totally fine. You don't need to be worried about that at all.
Okay, yeah, my question was more about, I kind of realized from the fact that it was just using it as a backplane and really not, you don't have to muck around with SignalR. My concern was, if there's any kind of performance, but it seems like almost it's complementary and it actually boosts performance in certain cases. So that makes me feel good about using that.
Right.
All right, people, any more questions for Shaun?
I saw people drinking beer even at the beginning and I feel jealous. So I think I deserve a beer now.
Yeah. So,
Absolutely.
so we'll try to have these meetings, once every few weeks or so. So we'll make sure that next time we drink beer at the end. So feel free to join us at the next meeting and we'll all drink beer.
Okay.
Maybe we'll like do a chug bottoms up or something.
All right.
All right.
Thank you very much. I appreciate your time.
Thank you.
Thank you. Really
Yeah.
appreciate it.
All right.
Thank you.